Welcome. Today we'll be solving exercise from the International Mathematical Olympiad. We are given a triangle with the area S, 8 side lengths A, B and C. We need to prove that this inequality holds. We know from the Heron's formula that the area of the triangle is nothing like 1/4 times square root of such a nice sum. 2a squared b squared plus 2a squared c squared plus 2b squared c squared minus a to the power of 4 minus b to the power of 4 minus c to the power of 4. We'll be using this later. Since we are dealing with a triangle, we need to assume that these inequalities holds. Okay, now we know that the square real number is non-negative, so the sum of squared real numbers is also a negative number. I will choose real number as a squared minus b squared minus c squared, and a squared minus c squared. Now let's use the formula for the square of a difference. We have nothing like a to the power of 4 minus 2 times a to the power of 2 times b to the power of 2 plus b to the power of 4 plus b to the power of 4 minus 2 b squared c squared plus c to the power of 4 plus a to the power of 4 minus 2a squared c squared plus c to the power of 4 is bigger than or equal to 0. Okay, so now let's add up the similar monomials, which are a to the power of 4, c to the power of 4, and b to the power of 4. We got nothing like 2 times a to the power of 4 plus 2 times b to the power of 4 plus 2 c to the power of 4, and minus 2a squared b squared minus 2a squared c squared minus 2b squared c squared. Let's multiply this inequality by 2, and we've got 4 times a to the power of 4 plus 4 times b to the power of 4 plus 4 times c to the power of 4, and so forth. Okay. Now we know also that the square of a sum of three numbers is nothing like okay, so we'll be subtracting 3 times a to the power of 4, 3 times b to the power of 4, 3 times c to the power of 4, and adding 6a squared b squared, 6a squared c squared, 6b squared c squared. So we've got on the left side of the inequality another nice sum. And on the left side of the inequality we've got Okay, now let's add this sum in easy way using this formula. And let's factor out 3 from this sum. Okay, we know that this sum is non-negative number because the area is non-negative number and the square root must be then also non-negative number. So we can square root both sides of this inequality and it will left us with okay, we see that the only thing we need to do is to multiply right side of the inequality by 4, and since we can change the value of the right side of inequality, by 1/4. Okay, so now we can see that the underlined part is nothing like our area of the triangle. So let's replace the underlined part by S. And since multiplication is a commutative operation, we can finish the proof. Thank you for your attention and see you in the next video. It's right in the corner. Bye.